This is a C++ programming video lectures. Today we will study copy constructor. For this lesson we will need the following resources. Some rules, like this, some pictures about our classes, and very convenient tool from Microsoft compiler, crt dump memory leaks function. It helps us to detect all memory leaks in our program. But let's start step by step. First of all, we need to review our last work that we created, our class array, which we created at last lesson. Class array. It consists from some members: size of our array, this is count of integers in our array, capacity, and pointer to array of integers itself. It has also constructor, destructor, and some function to add values and to show them on the screen. Let's look at our main. Here we create our array, object of our class, add to it 4 elements, 4 ints, and show them. Let's compile this program and start it. Let's enter some value, 2 for example, press enter, and let's see what we have here. Here is creation of our object. This is trace from constructor. Look, every our function in our class has some trace. I call it diagnostic tool. Here we put on the screen address of this object in memory and address of resource, integer array itself. In constructor we allocate some memory for array of integers, and in destructor we return all memory to system. Let's look again on our console. Here is creation of our object of class array. This is address of this object in memory, and this is address of resource. Here some calls of add memory function, and we see here that it allocates a new memory, it increases array, and this is new addresses of resulting array of integers. Here we see the destructor call, and it delete our memory. But for better diagnosis, we call in our destructor 2 trace functionalities: before deletion and after deletion of memory. Let's do something a little more difficult. Let's create in our main additional object of class array, but this time we will create it this way: array object R2, but this time it will be based on last object, an object R. We had made this functionality on base course with simple types, with ints. For example, let's create 2 integer variables, a equals 5, for example, and int b based on a. Here the variable b is initialized by the value of variable a. Here is performed shell copy, when every bit, every byte of this variable, of this memory, is copied exactly on this variable on variable b. These in these cases are called initialization. In the classes, when we work with classes, we can do the same this way. Here is the same initialization when we create our object based on previous one. Let's see what we will have, but at first we must comment these two lines of code. Later I will explain why. Let's compile and execute. Enter some size, enter, and now let's look at our output. First of all, we see one constructor and two destructors. Look at main. Here we see, here our first object is created, here created our second object, but we see no constructor. Let's look at some rules. Here in this document I wrote some C++ rules that we need to understand all topics in today's lesson. For example, constructor is called always when memory is allocated for an object. Always. Next rule. Every class has 4 default functionalities: constructor, destructor, copy constructor, and assignment operator. So, if in this case we see no constructor, that means that here is called default copy constructor. Here. But let's take attention on this trace, memory leaks. Now let's uncomment these two lines of code, because we have memory leaks. Let's uncomment. Now we will return all memory that we allocated previously. Let's compile and execute. Now we have error, critical error, our program is crashed. Let's see at our trace. Look, here we see first call of destructor. Our second object, look, this is address of our first object, FF40, and here is address of our second object, FF20. And by the law of the stack, last in first out, the second object will be deleted first. So look at our diagnosis, and here is called destructor of second object, and it successfully deletes all its resource that was placed on this address. But look here. Here first object tries to delete memory at the same address. This is impossible, because if we already deleted memory, we cannot delete it second time. Look, this line is first diagnostic line in our destructor. This line is called before deletion, but this line can be called after deletion, but we don't see second line, we see only first line. So exactly at this point our program is crashed. So that means that default copy constructor is not suitable for our program, because he leads, use of default constructor leads to memory leaks or leads to crash of our program. So in this case we need to write and define our own copy constructor, because look at the rules. This rule, this time, when we declare in a class our own constructor or copy constructor, it replaces the corresponding default one. So we must declare our own copy constructor. Array const array reference r. But let at first look at our pictures. We need this picture, this rule, and this picture. Look, default copy constructor and default assignment operator perform only shell copy. What is shell copy? Shell copy is when our operator or copy constructor copies only a stack of the class. What is a stack? Stack of class consists from all data members that are declared in a class declaration. The size of any object equals to memory allocated for class stack. Let's look at our drawings. Here is our code from main. We created object of class array based on previous one. This is performed shell copy. Look, this is object of our class array R. For example, it has 4 members, 4 values in array of integers, and this is its previous size, its capacity. Look, this is array of integer that is placed in heap, and this is address of this array of integer. When we perform shell copy, all stack of the class, size, capacity, pointer is copied exactly to the same memory in second object. But for simple times it's not bad to copy them exactly. But for integer it is prone to crash, because in this case both pointers are pointed to the same address. This address is stored in first object and the same address is stored in the second object. This leads to crash of our program. But let's see on this picture. We must perform deep copy. What is deep copy? Deep copy is creation of our own resource in second object. Look, here in first object we have integer array placed in the heap on this address. Performing deep copy, we must create to our second object another chunk of memory, and of course at another address, and after that we must copy all content of first array to the second array, and this will lead to no crash and no memory leak. Let's define our copy constructor. Let's copy this line and let's place it in our class array definition. Here we can copy all our initialization right here, these words, and here we must copy all data from R object to the right of created. R point, M size, next capacity from R capacity, but array we must initialize by 0. Unfortunately, I must finish this lecture because I can write only